So, welcome to the British Astronomical Association Hydrogen Line group here on the 4th of August 2025. We've got a small group today, but you're very welcome. Some people from America, people from Britain. It's a bit of a choice. It seems to me that the American people seem to have bigger houses than the British people, but or at least they give the impression they have anyway. So I don't know. In terms of what we're going to talk about tonight, so I've got a little bit of something, which is a little talk I prepared, which is easy radio astronomy in a single command line. I thought that would be just something to give a try and see how it worked as a talk. It might not work, but that's something I thought might be a bit of interest. And then I don't know, Ted, whether you would like to talk a bit about your TACO telescope, give us an update. I don't know if you feel like doing that or not, if you feel it's worth it, and I don't know what else anybody's got to talk about.
Well, I'm happy to listen to this evening.
Well, I'll give everybody a chance anyway, same as we do in the Drake's Lounge for the SARA meeting. So shall I get started just to get us all moving a bit? So I'm going to just share my screen. I'm not promising this is going to be any good, by the way, but where are we? Slideshow. So, it's not that many slides, in case you're worried. So I just put this in. I mean, obviously, all of us here know about Ted here's program, Easy Radio Astronomy. We've talked about it enough. But I put that slide in so anybody looking online at the YouTube can see the link if they want to try and download it and realise it's for Windows or Linux. And of course, it does what it says on the tin, which is make it relatively easy to do hydrogen line radio astronomy. And it's got a series of scripts written in Python, which allow you to collect data and to process it and produce a whole range of different plots and maps, including mapping out your data to show the arms of the Milky Way. Oops, I've got somebody trying to come in. Use my sound. Oh, it's Ted again. We lost you, Ted, for a while. You seem to have come back.
This is the brother. I'm tilted the other way.
So I'm talking about easy radio astronomy in a single command line. That's a little talk I prepared. I don't know how good it is. We'll have a look anyway. So just summarising for the YouTube video that this is just giving them a link to your GitHub repository there in case anybody wants to try downloading it. Commenting that it's for hydrogen line radio astronomy and goes on Linux and Windows and does what it says on the tin, which is makes it easy to collect and process hydrogen line radio astronomy data. So here's a picture showing that data being collected. We have some interesting stuff on the SARA forum with somebody who is concerned about the data they're collecting and having some difficulty. And I noticed that they're sort of, if you look at the red at the bottom, that their sort of red line was sort of all over the place. This is data over as you see, 24 hours there. And then you've got the light blue, which is over the last hour, and recent samples, which is the dark blue. And you probably notice about these tracings is that they go up and down in a zigzag fashion, which is that every other sample is actually a reference sample, 3 megahertz away at 1423 megahertz, which is used to actually calibrate the data that's coming through. And the graph on the left hand side shows a typical collection plot showing hydrogen coming through at 1420 megahertz and being collected by the program here called Easy Coal, EZ Coal, which is used to collect the data. So that's what I'm going to talk about today, say about one command line. It's going to be about Easy Coal. So again, this is just showing, again, just as much for the YouTube video as much as anything else. This is just to just move that out of the way, so it's on the video, goes in the way. What we've got here is the 1420 megahertz, which is the hydrogen line. But the most obvious thing that hits everybody as soon as you see that is that what I'm getting is a peak that's quite broad and certainly not just on 1420. and that's because some of the hydrogen is Doppler shifted to the left and some is Doppler shifted to the right, and that's because the hydrogen relative to us is moving at different velocities in the Milky Way. So that's because of that velocity difference in the different bits of hydrogen, that's how the software can then turn this into the incredible maps and plots that it does produce. Without those Doppler differences, we wouldn't be able to see that information. Just move that back. So, excuse me. Right, so when I say in one command line, this is the batch file that I use at Lichfield Radio Observatory, which is named for my backyard, for collecting data off my hydrogen line scopes. Now, there's a couple of ways you can do this. You can actually put all these parameters into a parameters file, which is then accessed by the program, but I prefer to put it into the command line so I can see exactly where it is, and as I use it in a batch file, I don't have to type it in every time. So the one that I've highlighted in yellow is a single line that is the one that runs the EasyCol program and gives these various parameters, each one started by a little sort of negative sign, and you can see they all start with Easy RA, and each of them allow for various things to be done, which I'll go through in a minute or two. At the top there, just to finish off what the batch file does, it just simply sets the folder that we're going to use to run this software from, and then it runs and where the data is, and then it runs the actual command line. So if we look at this one by one, just go back a second. So obviously looking back at the beginning of that yellow line, you've got py // easy ra / easy col.py. So that's the bit that actually, first of all, takes you back to the relevant folder where EasyCol is located, and then runs the EasyCol program. So these are various parameters going by one. So EasyRA obslat, long and AMSL set the latitude, the longitude, and the height above sea level. And then EasyCol azimuth and elevation that I put in there are setting the direction the telescope is pointing in azimuth, i.e. is it pointing direct south or direct north or somewhere else in between. You can use anything you want really for EasyCol. And the elevation. So the way these telescopes work is they're quite simple. Or at least it's complicated as far as software is concerned, but simple as far as the telescope's concerned. You just have it pointing in a particular direction, and then over 24 hours data is collected in what's called a drift scan. So as the Earth rotates, it passes through 360 degrees of the sky, and the software then calculates the different points along that axis as it goes through that 360 degrees, and therefore creates a data set that covers the full 360 degrees. And you do that for a while, and then you at least 24 hours, and then you change the elevation, and it gives you another 360 degrees, and you keep changing the elevation until you've got quite a big data set, and then you can do the mapping exercise. So all that your mount needs to be able to do is to point rigidly in one direction, and for the elevation to be changed when you want to every few days. The EasyCol center frequency ref sets the reference frequency that I mentioned at the beginning. In this particular case, we've got it 3 megahertz below the 1420 megahertz of hydrogen, where we know that there won't be any hydrogen picked up 3 megahertz away. On the original plot I showed some time ago, I mentioned it was 1423, which is just 3 megahertz in the other direction. You can sort of pick and choose what you want, really, as long as it works for you. And then and this is the one with the zigzag, that is the every other sample, which is then used to calibrate the data. What else have we got here? I've also got in my command line EasyCol bias T on. It used to be that you used to have to run a program called bias T on and off, which would actually, before you actually started Easy Radio Astronomy, which would actually turn the bias T on to power up the Sawbird hydrogen line, low noise amplifier and filter that we use on these telescopes. But now you can put it into the command line so that it switches on for you, and therefore you don't forget to do it. EasyCol integ quantity actually tells the program how many samples to actually integrate into a single data point. In other words, it sets how long in time each data point is, whether it's half a second or 1 second or 2 seconds or a millisecond or whatever. My telescopes are around the 1 meter in size, and for that there's an argument that there's not really much benefit in having samples that are shorter than about 4 seconds. There are some other advantages to shorter samples, but simplistically, about 4 seconds, or 3 or 4 seconds anyway, you can't get any more you can't get any more detail out of the data at a smaller time scale than that. So here on this particular telescope, 280,000 gives me about 3.5 seconds. The actual number that you use is different between telescopes because it depends on how fast the machine works and how fast your receiver and everything else will actually transfer data. So the two different telescopes may have a different number for the same time length. And in fact, I have 3 hydrogen 9 telescopes, and they all use different numbers for the same time length. I did mention there was an argument for shorter ones. The argument for shorter ones is that you can then discard data that has RFI, etc. in it much more easily without losing too much data. So it's horses for courses to some extent. Easy coal ref action doesn't actually change the data you collect, but it changes the way it's displayed on the screen while it's collecting data. So I use 1, which is something called ref div, which means it divides the sample that's being collected by the reference sample at 1417 or 1423 megahertz, and that gives you a more obvious peak, which makes it easier to see what's going on, but that doesn't actually change the data that's in the data set. And then the thing that says easy RA obs name is actually the title that you're going to use for the file, which may be just the name of the observatory, or it may be, as I do, I tend to put a bit more information in there so I know in the future what I'm doing with it. Just make for rather long names, and maybe there's some argument for not doing those, but at the moment I'm still using these longer file names. So I've just done here, I'm not going to go through all of these, but just to say there is a variety of other parameters that you can use, which will either be in your command line, or alternatively you could put it in a parameters file, what it's called defaults.txt, that the software would then use. And you can see, for example, that you can set the gain, for example, and some various other bits and pieces if you so desire. And again, I'm just not really going through all of this, but as much as anything, I'm showing these slides so that it's on the YouTube video for anybody that wants to look at it in more detail. And a few more here. USB relay is because the option exists in the software as a form of calibration to actually get it to switch in and out a dummy load, and you can use this for that purpose if you so desire. I haven't got that on mine, but the option exists. And as you can see at the bottom, if you want to use a defaults file that has all this information within that defaults file, you can actually set the name of the file. And that's my talk finished. Thank you very much.
That's very good. Yeah, that's very useful.
So in choosing the I believe it was that integration speed, is that you just sort of empirically hunt for a particular speed that seems to give you a better data collection, or how do you arrive at that number?
A finger in the air, see what happens, and then double it or half it.
I see. Okay.
And keep going until you got it about right. But I don't bother to try and get it exactly on a certain time period. It's sort of 3 to 4 minutes. And my main, I know that TED uses much shorter time periods, and with some justification, which is that he can discard the bad data more easily, and of course he's quite correct in that. But what he does is he processes the data every day to produce an intermediate file called an EZB file, which is probably the ideal way of doing it, but I'm a bit sloppy on that. I tend to just only process it once in a blue moon, so I end up with enormous data sets. I now have processed up to 500,000 data points at a single time. It took about 5 days to get through it. So if you use a longer time period of integration, you've got less data, and therefore it's easier to process it.
So what is the relationship between that 280,000 and a particular time of seconds? Is there some relationship between that number and the time?
Well, let me show you. Let me just share again, and I'll show you something that perhaps would give you an idea of that. So,
the speed of your computer.
Yeah, exactly. But I can demonstrate that more, perhaps a bit in very vivid terms. So I have three hydrogen line telescopes. So this is H1, which is my ptarmigan array. And on that one, you can see that these are all running at about 3 to 4 minutes. So this one's got 280,000 integration quantity. The one that I've been making out of a 1.5 meter solar cooker has got clearly a faster computer running, because we've got 550,000 here for its integration quantity. And the one that's made of here we are, doesn't even do anything at the moment. That's one that's from Ted's 13 element array, which seems to have conked out. Don't ask me why. So you can see there between the 280 and the 550 that there's a twofold increase between those two telescopes to get about the same length of time.
So as you said, you just see what works. If it doesn't, you double it or something like that.
Yeah, that's what I did. But I'm sloppy, I admit it openly.
No, it's just an empirical choice, I guess. It's Ted kind of mentioned there the speed of your computer and so forth. So yeah, I was just curious if there was some specific relationship that was like a standard value that you put in for, say, a 4-minute observation or something along those lines.
What do you use on yours, Ted?
It's just a count, and commonly I just set it to about, I don't know, 15 seconds or a minute or something like that. You could certainly put it up to about 5 minutes. After that, I suppose you're starting to smear the data across your screen because you're just waiting too long before writing down samples. The samples look gorgeous, but they are smearing. And I just don't pay too much attention to it. You can either average them and before you write down the sample, or once you get samples, you can average the samples later. And that's what Easy Sky will do across the sky. And so I use smaller samples just so that if there was a lightning splash or something like that, then I could remove a smaller bunch of data to throw it away. But it makes bigger files, I guess. You can make bigger files also by choosing the number of frequencies that you are recording for each sample. The default is 8 bits worth, which that's 256, but you can make it bigger. You could have a larger frequency span that might have more of those frequency bins. That's true on an Air Spy, for example. It'll pull in 1,000 frequency bins, and most of them are just not used in hydrogen. I think it can be said that if you pull in that many periods and data samples in time, that you're getting a crisper, cleaner spectrum. But I'm not sure I care yet. Maybe I'm the guy that designs the computer instead of the software. So I just worry about making that happen instead of the actual results. Long answer.
What's a small sample time, and what's a long sample time?
Because of the Earth's rotation, I suppose it's all the same. It has to do with what is the beam size on the sky from your antenna. If you use a 60-foot dish, you better take samples quickly because the sky is moving along quickly. But commonly we're using these like 1 meter dishes or small, or maybe a little bit bigger. And so with a 1 meter dish, Alex suggests that it might be a 5-minute sample before you get any smearing. And if you do that, then gosh, yeah, there's a whole bunch of random noise that's canceling each other, and you get a nice, pretty spectrum. Is that what you're looking for, spectrums? Or are you looking for plotting it on the sky? So
Yeah.
there are different goals.
Yeah, so we had a 21 centimeter dipole.
Well, okay, so a dipole, just wires in the air, would not have much directionality.
Yes.
So a big, long sample is possible because you're looking at a whole bunch of the sky all at once every time, and therefore you don't need many of those samples to cover the whole rotation of the Earth.
Yeah. Okay, that makes sense. Yeah.
I have some vague recollection that dipoles are about 120 degrees. Is that right, or am I wrong?
I think it picks up from 180 all over the place.
180.
Yeah.
If you put a ground plane on it, now you're starting to make a beam. If you put directors on it, now you're making a tighter beam. And then we get up to Alex's mini director antenna. And that's supposed to have a smaller, what should I say, footprint on the sky? Field of view.
Yeah, that's good. Because I'm looking at, I'm going to build a dipole. I found, so I took your advice from the last session. I think, did I miss the last meeting? I think I did, yeah. And so I looked at the dish antenna, and it's about 200 quid, which is fine. But I've just spent, I'd upgraded a telescope, visual telescope, from 150 quid to 500. So I thought my budget might get challenged. So that made me look at something smaller and less expensive. So I found an article that actually covered dipole and lots of other telescopes. And I thought, okay, I'll build the dipole and then I'll move on later to getting the mesh. So that's my next sort of project. I've actually received the semi-stiff cable that I need, a coax it uses, semi-rigid coax, that's the word. And so I'll build that, and then I'll do a 10-hour sample time or whatever you recommend, Ted.
That's quite the sample time, 10 hours. Wow. So you get about 4 lines in a data file for a day. Wow. Yeah, okay.
It's a big computer. Yeah.
There are a lot of simple antennas that you could make quickly. I document some, or at least I have pictures in the Ezra pages under Hardware 1, and so that's something to consider anyway.
Yes, yeah. I'll paste the one I'm thinking of. Hang on a second, I'll just get this screen thing going.
Yeah, can you share your screen at all, Tony, and show us a few pictures of what you're thinking?
Yeah, sure. I could do that. Yeah, hang on. I'll just find Teams. So I'll share my screen. With all the backgrounds there, I thought actually the screen was being shared. So hang on, I'll do that. Select window or screen. Entire screen is fine. Allow. Right. Am I sharing?
Yeah, I think so.
Okay. So this is what I found. So this is just using some semi-rigid coax, and so I did ask actually the local radio club as well, and they said, don't bother, it's not worth doing, you'll get nothing, too much noise, But actually, this article was interesting. I don't know if anybody's seen it before.
Yes.
But yeah. So I thought, okay, so there is a dipole in here, which is this one here. So I thought I might just start and make that first. And I've got the actual coax, which looks exactly like that. And I've got the filter as well, and a laptop. So I thought I'd just start with that and then move on. Get that going, see how that works, and then move on to using the mesh. It actually says in the article that actually the results are okay with this. So it remains to be seen. Obviously, I haven't tried it yet.
Oh well,
But
if AstroPeller say the results are okay, then the results are okay. Yeah, this is Wolfgang's mob. I mean, they know what they're talking about.
Yeah. So you're familiar with it, yeah? Okay, great, yeah.
Yeah. Have you seen this in action, Ted?
It seems to me that's a lot of trouble to make that dipole. Can I show you some other simpler antennas?
Yes, of course, yeah.
My little driven
I'll
element.
stop sharing here. Yeah.
If I try to overrule you, let's see what happens.
I'll stop sharing anyway. Yeah.
I guess it must be this one. It doesn't give me pictures. Let's try this. Share.
It does a
learning my
dipole. Yeah.
You didn't think of a cantenna, Tony?
I did, but I thought, I don't know, I wasn't sure. And then I found this. I thought, actually, that's all right. And for some reason, I got dipole in my head, so I just, the way you filter things, you think, right, so a cantenna would be a better solution, but you're thinking dipole, so you think, forget that, I'll just do dipole.
So at a Sarah conference, I talked all about this guy.
Yeah, I've seen that, yes. Yeah.
And gosh, it's cheap. It's actually better than this one. I mount the little wires a little differently. But you can see that there's a dipole inside that straw, and it's not very complicated. The straw just holds it in place. Mm-hmm. It's two wires soldered to the connector, and ta-da. But there are other simpler ones. You can get some insulating material, like for your house to put on a wall, and it's metal, or you could take parts from some metal appliance. I keep looking at dryers and I see these big sheets of metal on the side of them, clothes dryers. Anyway, but down in here is the electronics again, the LNA, and it's just got a stick coming out here, much like a cantenna, in the right in a place anyway. You can make a horn with a cantenna on the bottom. I have put a dipole just in front of one of these, and it sort of works. Then that guy,
yes, I'm looking at those. Yeah.
Just more. So and let's see, that's the connector I'm using. Well, maybe over here on this side. I guess this is just the same reversion. And I just soldered stuff on there. But also, I guess I don't have it here. There's a trombone version of this that is even more stable. This thing rotates right here at this joint. That's what the straw was for, to hold it in a straight line. Good luck. Be creative and learn new ways. I'm all for it.
Yeah, no, it sounds good. Well, there's plenty to explore. Yeah. And Andrew, when you do the observations, and you're sort of moving up what sort of number of degrees would you typically go between sort of readings from one night to the next?
All depends, of course, how big a footprint on the sky your antenna shows.
Yeah.
With a dipole, there's no elevation. I don't know what you would do anyway.
Once you get
a pointing beam with directors or a reflector, at least, you can start rotating it around. Again, if you had a really big dish, you can make itty-bitty tiny elevation changes, and it might matter. With a small dish, it's not going to make any difference. I have an example coming up if that helps.
Cool.
The on mine, the first map I did had 6 elevation points,
Right.
which I did over a couple of months, and then over a few weeks you could do it. Really, it just took me a couple of months to do it because I was busy elsewhere. But now
the patient approach. Yeah.
I probably about 18 elevation points. I have some sticks on the side which use the high technological solution of just drilling holes in the sticks at periodic intervals, and then just moving up to the next hole if I want to change the elevation.
Yeah.
So it's about 18.
Yeah, it works. Yeah.
The galaxy really isn't changing too much over time. So if you go back,
I hope not.
you know, 6 months later, okay, you can go fill in the holes.
Yes. Yeah. Unless this new comet comes and causes trouble and bother in the solar system.
No.
What, I3 Atlas?
Yeah. Yeah.
Yeah. That's just inside Jupiter right now, so that's still way out there.
Yeah.
Yeah. So
Waiting for a train, I guess.
I think I mean if you can find some electrical insulating tape left after Ted has used it a whole lot on his Yagi, I think his Yagi is not a bad next step up from your dipole, because it really is just your dipole stuck at the bottom of a plastic hole with some various directors stuck out, isn't it?
Yes.
And you can make the directors very easily from straightened paper clips if you want to keep your price down.
That's creative. Yeah, that's creative. Yeah. Very good. But I'll let you know in the next session. I'll let you know if I manage to solve it.
I think
it's a bit fiddly.
That first dipole that you had on there that had the kind of extension below that, there's a functionality for that, because a regular dipole, I don't know if you're familiar with impedances, but the input impedance for your receiver is going to be theoretically 50 ohms, and a straight dipole has a slightly lower impedance. I think it's like around 36 or something ohms, and so that stretch of those two extensions that come out below that looks to me like what's called a ballon.
That's right.
So that ballon then is an impedance matching to the 36 to your 50 input. So in receiving, it doesn't make a huge difference, but I mean it can make a slight bit of difference in terms of the loss of the signal that you're going to get from the antenna, whether it's matched or not. So I think that's why it looks a little bit more difficult than just a straightforward quarter wave dipole that you just extend out.
Yeah, it took me a while.
Even as Andrew's saying, it's very simple to just sit that thing inside and build it kind of inside like a PVC pipe, and they just drill some holes along the length of it. Just calculate out there's a lot of online formulas for you to be able to add a couple of directors and one reflector behind it, and boy, you can make a heck of a lot better directionality out of that thing than just a straight dipole.
And it's a good idea actually as well with the PVC.
And increase your signal, because that dipole is going to be just very weak.
I imagine it's going to be horrible. Yeah. But that's the expectation. But
I caution you. We learned by experience that insulation on the wire changes things. And I suppose passing through a PVC pipe will change things. It changes the effective length of your wire, and of course the wire dimension has all to do with its receiving capability or directing capability. So I learned about bare wire made a difference. When we used insulating wire just to be lazy, it didn't work. It just did not work. And so passing through a PVC would be the same kind of problem. Maybe the straw, I don't know. So I am cheating in many ways
there is straw nearby, so I can try that,
beware, though,
Yeah, of course,
So the later design of that long PVC pipe, I put the wires on the outside of the pipe instead of drilling through. And I can get you that design.
Yeah. Yeah, it's everything makes a difference.
Oh, no, it's a video actually up on
Yeah.
Desert.
Oh, very good.
That's
Yeah.
right.
Yeah.
It was a presentation at a conference.
Have you stuck that in the chat?
Sure, allow me.
Okay.
It's over here someplace.
So, while Ted's doing that, is there anything else that you'd like to talk about, Tone?
Oh, no, that was it. That was it, really. Yeah, and I'm looking forward to the conference, the UCARA conference in September. So looking forward to that.
Oh, it's good you're coming along.
I think,
That's excellent.
Yeah. My wife said she's coming along as well. Now she doesn't know anything about radio astronomy, but she said she's coming along. So we'll see. Yeah.
Are you going to come along to my Nano VNA workshop?
Absolutely. Yeah. And I'm happy to spend a bit of time at your display as well. Yeah.
Oh. Adrian's showing that he's got access to the Starship Enterprise's transporters. He comes in and out.
Here's
it's coming in and out of the void. Yeah.
I don't know if you can see that, but that's and I don't have the other end of it, which fits over here with some directors. I actually made this for the low end of the 70 centimeter ham band, around 430 megahertz, to use to track ham satellites. And so so you can just do something like this, and it's got the nice handle, the connector on the bottom here, which goes to the receiver. Yeah. And this worked really well. I was able to get some really good signals out of it. And so here's the dipole end of it. And it's you can't see inside, but the coax runs through the bottom of it and then connects to the two sides. And this is just the matching stub here. I don't know if that's visible. The matching stub. And then over here on the back is the reflector. This back flag. And I just used some aluminum tubing that you can get at hobby stores. And and then the joining piece of another set of PVC that goes through here extends out another 2 feet with about 5 directors on it. Yeah. So this is something you can build pretty cheaply. I mean, it's a little bit more expensive than that dipole, but something like this would give you a little bit much of a better beam than you would from just a straight dipole. Like again, this is the wrong frequency, as I said, is for 435 megahertz, not 14. But you just scale it, and you could use the same sort of concept.
Good design. I like the handle on that as well.
Yeah. Well, because it's for a handle. Because if you want to track that satellite across the sky, you want to be able to move as good. So that's why I built it like this. And it's got I've sort of kind of looked at the beam out of it. It's not perfectly a main lobe. It's got a couple of side lobes to it, but heck, it's a heck of a lot better than just a straight dipole. And like I said, for picking up ham satellite signals across the sky, and again, just you can just scan it. I mean, if you look at your track, if you have the software where you can see the track, you can kind of get an idea where the satellite is, and you can just sort of manually sort of move it around. Yeah. So something like that, like I said, it's just PVC tubing, some aluminum tubing you can get if you want to a little bit more bucks, and or what do you call it, quids, and off you go,
Quid,
You can just put this on some kind of a stand and do your.
And off we go,
Yeah. So I mean, this is something you can cook up pretty readily.
Yeah, that's good. Looks good. Yeah. I like that. Yeah. I like the shape of it as well, the geometry. Yeah.
Well, like I said, I needed to be able to handle it and be able to sort of point it.
Yeah.
And that was the idea behind it.
Yeah, very good. Ted, I see you posted that video, and I'll have a look at that later.
Fantastic. Thanks, Ted. Thank you, and thanks, Tony.
Good luck. Sounds great. Tell us what you discovered.
Yeah.
So Adrian, is there anything else that you would like to tell us about today, or talk about?
Oh gosh, I'm still trying to build up the hardware for observations. Like I said, I've done some preliminary kind of area surveys at 1420, and disappointed at the amount of RFI that I get in my location. So I'm not sure. I mean, as I've said before, I'm close to a military air base, and just even earlier, it was just like a whole parade of jets going overhead. So I get a lot of fighter jets, a lot of military traffic. And I've been able to sort of use this light pointing kind of a beam, little loggy antenna that I have around 1420. And a lot of that RFI comes from the direction of, this is the Miramar Air Base. You guys might have heard of before, and fame out of the Top Gun movies and so forth that was filmed there. So sometimes it's quiet though. We usually get a lot of that traffic whenever one of the carriers pulls into the San Diego Naval Base, and so before the carrier comes in to dock, all the jets take off, and I guess they go into the land base and land in Miramar and start doing all the exercises. They go out to the desert out of east of San Diego, and they have a range out there for bombing and so forth, and so they do a lot of that practice. And they're usually nice enough to stop around 10:30 or 11 at night so you can sleep. But I mean, they go overhead constantly during the day whenever, like I said, they're in town. And so during those periods, it's almost impossible probably the kind of interference that I get from that area. It's just really horrendous. But anyway, I still would like to make the attempt. So I'm working on the Cantana design. I want to try to incorporate it into a paint bucket. One of these paint cans that I can't find, like a coffee can of the type of dimensions. Everything's in plastic nowadays, so that doesn't work. So I came upon the idea of trying to use a new I guess gallon paint can that has about the right dimensions for the 21 centimeter antenna. And so I'm trying to get that built up first. And so that's kind of where I'm at. And then I've got still in the box one of your famous solar cookers, Andrew. I have not cracked that open yet. So, but I intend to try to use that for the reflector, and have to still think of some base to change it over from the system that they have for the actual solar cooking. As you said, it kind of looks pretty unstable from your pictures. But
why don't you just make a wooden one like I did?
Yeah, I'm thinking of that. I'm not very handy with woodcraft, but and it's not really too accessible in terms of any kind of secondhand lumber or something. And boy, I I don't want to get into it, but the pricing on just about all supplies have just skyrocketed here with these tariffs that we seem to be having over our heads in the U.S. right now. Wood, I had some work done at my house just recently, some dry rot that I had around the roof and so forth, and just the supplies for that were pretty incredible from the people that were doing some of the work on that. And yeah, I'd kind of like to make it something, because the wood around here outside just doesn't last very long. So I'm not sure.
Well, I appreciate what you're saying. We also have enormous price increases. Not only are we affected by the general rise in prices of materials, but our government decided to produce a new railway line up from London a number of years ago called HS2, and whatever else HS2 has done or not done, what it has done is stripped the country out of virtually all building materials and notched the price that was already high up through the roof. But so wood costs a fortune. The point about the mount that I made is that you can make it with anything. It doesn't have to be any particular sized wood, and you don't have to be very good. I just got out a hammer and a drill and banged a few bits together. I didn't even bother too much. I told you I'm a sloppy person, which I am. I didn't even bother to measure things very well. But when I changed the elevation or changed the direction, well, first of all, I found I could download an app on my phone that gave me a compass, and another app that gave me a digital inclinometer. They were completely free, didn't even cost me anything at all. I've upgraded the inclinometer to £8 one which I bought online just simply because it's more convenient. But the phone one worked fine.
Yeah. A
So,
posh one. Yeah.
posh one just to make it easier. But it's amazing. There's a technological thing that allows you to produce basically rubbish. The only thing the mount has to be is stable. So it has to be solid enough for that purpose. Locally here, I discovered that the local hardware store had a cutting room at the back where or a sawing room where they cut up wood for people, and in there were offcuts, and I could go in and buy a handful of offcuts for a few pounds. I mean, as far as the hardware store is concerned, they've already sold it to somebody, so they've already got their profit, and now they're selling it again to me. So they're doing very well out of the whole thing and don't have to get rid of it. But what I don't get is anything of any particular. I can't go in and say I want this particular size or even this particular thickness or this particular whatever. I get whatever rubbish is in the offcut tray. But you can bang and bash anything together, and as long as you've got enough of it, you can make quite a stable sort of table type structure, which is what I did. And using my posh technique of a piece of wood with holes drilled in it, and then we're very damp here, so things rotting is quite relevant, especially when it's cheap pine like this is. But I got a great big plastic container full of fence paint, which is basically water with a tiny drop of paint in it, mixed up in a few gallons. But about 400 coats of that seems to do the trick. And we have some very cheap, cheaper, I should say, German supermarkets. One I go to is called Lidl. Not that I'm trying to sell a particular make, but they sell cheap stuff. There's one or two others as well. They were selling some cheap spray paint, so I used that to spray the solar cooker, because the other problem with the solar cooker is it's only made, or even all these cheap satellite dishes, they're only made of simple steel, which is just molded. That's just one of its biggest issues. It's thin steel, so it rusts, as I discovered very quickly, in the British atmosphere. So you need to paint it and cover it so that it doesn't rust. Some debate about which paint's the best to use. We've had on the Sara forum, but I just use this cheap stuff from Lidl and spray it every so often, every few weeks, with another coat. But it's none of this is long lasting. You say stuff's not very good. I'm not expecting it necessarily to be still around in 6 or certainly in 12, 18 months time. But if I keep spraying it, keep painting over the wood, etc., it'll probably last. But when I give up and stop doing it, a bigger issue though, ironically, especially with something like the solar cooker, but I've had it with smaller dishes, is actually the wind grabbing it and blowing it over. I mean, Ted might be talking to us in a minute about his taco dish, if he's going to update us or not. But I haven't done any Go Taco, but I've certainly had one of these New Elect dishes blown over and discovered it wasn't very strong and cracked, and I had to use a Heath Robinson affair to repair it. So now I don't just have the wooden mount, but I've got it's on the grass on the garden, so I've got guy ropes and some very big marquee tent pegs smashed into the ground to tie them to hold everything from blowing over in the wind. So I think that's a bigger issue necessarily than other stuff. You just need to make something. It doesn't matter what it's made of. A load of junk you can make it of, as long as it's stable and solid.
Well, one of the things I've been eyeing is to see if I could find a discarded wooden pallet.
Yeah, perfect.
And then cannibalize that for the wood. And so that's kind of what I had in mind. If I could just find someone that maybe one of the stores that might have just thrown one out the back or something before it got picked up for the rubbish. And so I was thinking of try to pick one of those things up and then try to cannibalize that. And then and I've thought about it because we do get some pretty strong winds where I'm at. I have a kind of a canyon in the back of my property where I'd be putting the dish, and it acts kind of like a wind tunnel. that wind comes up and gets accelerated over it's like about a 300-foot drop down to the bottom of the canyon. When that wind hits it, and it's facing west, southwest, which is kind of where the prevailing wind is from here. And so when that wind kind of comes across the canyon and comes up that side of the canyon, it just kind of comes up into my property, and it's just like some pretty strong gusts. So I would definitely need to have some means of stabilizing this to the ground, because the wind area of that dish would just kind of like pick it up and make it into a flying saucer or something. So I was thinking of maybe pouring some concrete blocks or something into some buckets and just using them as kind of weights. It's hard to get stuff into the ground here. I actually dug, Paul, I do have an old, what's called a bud, the big satellite dishes that were popular back in the 90s and 80s, and I had one that I installed back in like 1993 in the backyard, and so it's on a pole on concrete, because I had that problem, and it's really hard to dig in my area. We have with this soil, it's called potato soil, and that's because every 2 inches you have these boulders of round boulders of rock, and so it's not soil, it's just kind of like loamy sand with these things just all placed throughout the area that you're trying to dig. So it's a real pain. You can't drive anything into it because you go down 2 or 3 inches and you hit all these boulders. And
well, in that case, can't you get a bag, like a canvas bag or something, and tie it to the bottom of your mount, and then pick up all these boulder things and just shove it in your bag and create a great big weight and hold it down?
Make a big weight out of it. Yeah, I would have to dig a hole and pull out over a lot of those boulders.
Well,
but
or old bricks from somewhere.
All that kind of stuff is really difficult to find around here. I'm not sure what all those things either wind up in trash very quickly, or the big stores around here are the ones that handle all the supplies, and that's the so-called Home Depots. I guess is the chain that kind of predominates here in the States. And all that stuff is fenced in, so it's you'd have to maybe go in and see if they have any, as you mentioned, the woodcuts. I mean, that sounds like a great idea, and I know they do a lot of.
What about eBay?
Supplies. Oh, just stuff out of eBay. Yeah, you can buy stuff out of eBay. I'm not sure how bricks and stuff would go on the mail, but there's a number of options here for tying it down. Yeah, so far my main concern has been but besides the physical construction, as I said, just the survey that I've done, and I've kind of looked at it and noticed that there are those periods of RFI when it's not so bad. Mm-hmm. But like I said, like right now we have a lot of activity, and so in between periods of sometimes when, as I said, when the fleet isn't quite in the area, it's a little bit quieter. But in any case, trying to do some progress on it. I had a question. I saw that you had purchased a duo, an RSP duo. I'm just curious if you'd had a chance to utilize that particular SDR.
I haven't got very far with it so far.
Okay.
Yeah, okay. No, not much of a chance.
It's a pretty nice receiver. I've got one of them, and it, I really like it. And I know Ted has mentioned before that he's tried, I guess, to do the connection. I did get the software from him actually yesterday for the other SDR that might be useful besides the Newelec, and so that might be getting one of those might be an option over getting the small Newelec SDRs for the software.
So if you don't mind, I'll contact you outside of this group to ask you about the duo, because I could do with some help getting it up and running.
Oh, sure, absolutely, yeah.
Yeah, it'd be great. Well, thank you very much. Thank you. Okay, is there anything else you want to mention, Adrian, at all?
No. not in terms of the radio astronomy. I basically I'm trying to. The presentations yesterday were really excellent. I really enjoyed the art talk yesterday. There were some presentations about some of the recombination lines from the gentleman in Russia. I forget his name offhand.
Dmitry, isn't it, Ted?
Dmitry, yeah, correctly, yeah. Yeah, he had some really fantastic presentations yesterday of some of the observations that he's done with the GBT. I'm just curious if you had any further observations of the extragalactic H1s.
Yeah,
the other galaxies.
Jason and I have been setting up some more observations. We've been looking at M81 and M82, and particularly looking at the area between the two galaxies. But we're running into a bit of an issue at the moment, which is the original plan was to try and so for people. So I should say for people who are just coming into this meeting, who perhaps don't know what on earth we're talking about, perhaps got very little to do with radio astronomy and to do with SARA. We're talking about the 20-meter Skynet dish / radio telescope, which is at Green Bank Observatory in the United States, and SARA members, which is Society of Amateur Radio Astronomy, have access to use this dish. It's brilliant. So I always go around and say to the astrophotographers in my home astronomy group here, I say some of them have got access to a remote astrophotography setup that's in Spain. That's maybe a few inches across, and I say, oh, you've got a few inches across there in Spain. Mine's at Green Bank Observatory in the US, just 20 meters across. Beat that. So trying to show off, mine's bigger than yours. but anyway, so SARA members have got access to this, and it's quite an incredible opportunity to do some very serious radio astronomy on a professional size telescope. And Jason Burnfield, as a member of SARA, and myself have been doing a number of observations, as Dmitry has been doing, as Adrian here has mentioned. And so Jason and I have been looking particularly at extragalactic sources. They're all extragalactic sources, but looking at galaxies outside the Milky Way, I should say. And so we were looking at M81 and M82, Messier 81 and Messier 82, two local group galaxies, and we were trying to see about the area between the two to try and work out whether we could tell whether the two galaxies overlapped each other in terms of their hydrogen in the exterior of the galaxies, or whether there was actually sort of real space between the two galaxies. We think we've just about worked it out now, that in fact there is quite a lot of connection between the two galaxies, but the problem we've come across is to suddenly realise that the beam width of the telescope creates an issue. So how much sky the telescope actually covers means to some extent it is difficult to actually get enough space and the beam width between the two galaxies to be able to say whether there is space or not. We've ended up actually, for anyone who does astrophotography, this may sound a bit weird, but we've ended up using dithering, if any of you know what I mean, which is so in astrophotography you can get a business where you can actually improve the resolution over the resolution of the camera by realizing that the space between 2 pixels you can calculate roughly what the value of almost like an extra pixel between the two is, based on just looking at the 2 adjacent pixels. And we've managed to get up to a sort of 3 times resolution, 3 times dithering on the 20-meter telescope between M81 and M82, and just about ascertain that that they do actually overlap. And if you actually then compare that to professional data, which is published in the astronomical research literature, you can see that isn't indeed the case. There is actually a bridge between the two. There's also a space to the side where there's some real space, so it's also more complicated than that. But the two do actually meet each other at one point at least. So that's where we're at the moment.
Well, that's really interesting. Yeah, so I hope you'll be presenting that at some point. Definitely love to see that.
Well, we've got a paper coming out in the next SARA journal, which gives the data that we presented at the Eastern Conference, together with some of this extra data now. So you better see that there.
Yeah, that's very good. It must be very satisfying actually to do that. Even I guess maybe 50 years ago, hard to do. Certainly for us, anyway.
Well, we're in the lucky position at the moment. The only people who are using this telescope with any meaningfulness is ourselves and Dimitri. I don't know why the rest of SARA members don't use it.
Yeah, don't shout too loud,
I've used it a few times. I actually did some raster scans of the Orion gas molecular cloud with 1665 hydroxyl macer detection.
Oh, okay.
And so that kind of shows up very, very nicely at 1665 and attempt at 1612, the other emission for hydroxyl macers. But the RFI at 1612 is just horrendous there. So you can't really, I could sort of discern the area on the raster scan, but there was so much RFI surrounding it that was really not very clean. But yeah, I haven't used it as much as I should have. But
so when you say raster scan, I assume you mean the 20 meters own inbuilt mapping option.
Yes.
Yeah.
Right. You can find it as one of the settings for the tracking, where you can specify a raster scan of the area, specify the dimensions of the angular dimension that you want to have the raster scan of, and then obtain that. I was thinking maybe I could show that if I could ever find it. Let's see. If I could find.
Well, I'll tell you what. While you're trying to, we'll come back to you in a second, Adrian.
Oh, okay.
While you're trying to find that, I'll just pass over to Andrew here and ask him. Andrew, would you like to talk about anything while Adrian's trying to find that?
Well, after the last session, I decided that.
Sorry, forgive me. Are you able to turn up your, or put maybe your? I see your microphone looks like it's up on your head. Can you? Let's pull it down a bit.
God, yeah. How about that?
That's definitely an improvement, I think.
Okay. After last session, when we talked about ways to improve signal noise, and we were talking about the difference between linear power source and switching power sources, I thought I'd do some investigation. So I got a linear voltage, linear regulator. Mm-hmm. And so I put it in between the switching power supply and the amplifiers and the filter, and I reran the scans, and I ended up with more noise signals than I had previously. So I thought, this is odd. So I took the linear regulator out again, and the same noise signals were still there. So I thought, this is strange. So at that point I thought, right, I'll use Cygnus RFI and try and do an RFI scan to find out where these noise signals are coming from. But once I started down that route, I found that the computer was no longer recognizing the USB devices. So I had to pack the whole thing up. While I pack the whole thing up to take it to pieces, what I'm doing is I'm upgrading. This is in the GNU radio, the GR Osmo Com, so that it will recognize two AirSpy devices. So I can do interferometry using two AirSpy dongles simultaneously. So I'm in the process of updating the computer and fixing the problems before I can get back to the hardware and do the scans.
Well, you've cheered me up a bit. Not because you've suffered directly, but because you've shown to me that I'm not the only person who tries to do something and the whole lot falls apart simultaneously. So at least to make you feel I'm not on my own.
Definitely not.
I always feel I must be totally incompetent. with that, and I, especially on the SARA meetings I go on. Oh, it's worse still on the British Astronomical Radio Astronomy Group meetings. I just sit there nodding sagely, pretending I understand a word that anyone's talking about. But,
It's a good way to do it. Yeah.
so if you watch me in your car, I'll be going, yeah. Always thought that was the case.
Andrew, how far apart are the air spies?
They will be very close. They will be very, very close together in the receiver chain.
Right.
And
close is?
They'll probably be within inches.
Right. Yeah.
Yeah, but at the moment with the GNU radio software, you can only recognise one device. You can't plug two of them in and receive signals simultaneously from both. But there's apparently a patch you can apply that allows you to do just that. And so I'm working on applying that patch, and then I will try out the hardware again.
Yeah, good little project. Yeah. Are you using Linux or Windows?
Yeah, it's Linux.
It's actually Linux, isn't it? It's got to be Linux, isn't it?
Yeah. I hate it, but I'm using it.
Yeah.
I mean, I've tried the AirSpy R2 and the AirSpy Mini, and I actually get bigger signals with the Mini than I do with the R2. So that's why I wanted to put two Minis in to do the coincident interferometry that I claim.
Sorry, the what interferometry?
Coincident.
Oh, what's that?
Yeah.
Because both the monopoles are in the same receiver, rather than in separate receivers.
Oh, right. Okay, I think
I understand
I'm lost.
Yeah.
Everyone else looks like they understand what you're saying, so we'll just stop there.
Well, if you see the dish behind Ted, and at the top you've got the feed horn, I've got two monopoles inside that feed horn.
Oh, right. What, inside the same feed horn?
Yeah, inside the same feed horn, rather than using the two dishes that one each side of Ted's head. So
are they in the same polarity, or are they like 90 degrees?
90 degrees.
Okay, so for two polarizations. Okay.
Yeah, and that's why I call it coincident interferometry.
That's what I'm trying to build.
They're both in the same place. Yeah,
right.
Oh, right. Okay.
Yeah, which is not a coincidence.
Yes.
Yeah, I'd like to do the same thing with the RSP Duo. That's because it's got the two built-in receivers and they're all synchronized, and then do the two polarities simultaneously. So that's what I'd like to apply that for. So have the two probes at 90-degree angles to get the two polarities. Yeah.
Right. That's interesting. So what can you see with that, or at least what can you observe with that?
Well, I mean, you get the same hydrogen line information, but what I'm trying to do is boost signal to noise.
Oh, okay.
Yeah, because with interferometry, you can add or even multiply the signals together, and so you should boost signal to noise that way. That's my theory. It's trying to get the hardware to cooperate so I can show it in practice.
Right. Okay. Well, thank you. Okay. Is there anything else you'd like to talk about, Andrew?
No, that's where I'm up to at the moment. I will let you know when I get sort out the linear versus switching power supplies.
Right, so that's still something to come back to for us to be waiting for. Okay. Did you manage to find your the image you wanted to show us, Adrian?
Let me see if I can show that. Let's see.
So next to leave at the top right, you've got share. So if you press that button.
Share. Okay. And
the best thing is just to share the whole screen usually, and then you can just choose whichever you want.
Then you have to find that. I'm not sure how you can do this in Windows. I'm not familiar with this.
What's that? Sorry, Adrian.
I'm sorry?
What are you not sure? Sorry.
Well, to even find the image, let's see.
Okay, fair enough. So while you're looking,
Yeah.
then pass on to you,
Okay.
Ted. Would you like to talk, Ted, a bit?
Yeah.
Or have we lost Ted?
I think I can. No, I'm here. Let's see. I think I'm even live. Yeah, all right. Let's see if I can push buttons and give you a little show of a happy example, maybe. Oh gosh, it doesn't give me pictures. It gives me names.
While you're looking for that, have you tried this coincident interferometry that Andrew's doing?
That sounds like fun. No, I have not. EPMO. All right, let's try that then.
Because you have done some additive interferometry, haven't you? With your Yagis. Oh, he's gone. Oh, we've lost him completely.
It's the Windows software. it's not friendly. It's not user friendly at all.
What did you press, Adrian?
Oh my gosh. I'm still hunting for how to do this. Familiar with Zoom, but boy, I'm telling you, the Windows software is just kind of a new game for me. Oh my gosh. And Ted just disappeared.
Just disappeared off the planet.
I see the picture. I've got it on my screen, but I can't seem to be able to place it.
If you've got it on your screen, you just press the share button, which is next door to leave, or between leave and microscope and mic, and then if you just then share the whole screen is probably the best to press.
I'm finally back. I'm ready.
But let Ted go first.
Let Ted go, please. Yeah, go ahead, Ted.
I knew share was up in the top right, and I hit the nice big colorful button that's now I see as leave. Oops.
Sorry. Same problem as you then, Adrian. Don't worry too much. They're retiring on ill health grounds at the beginning of September. Not long after which I will completely lose the ability to use Teams. So we'll have to be going over to Zoom.
Oh gosh.
It is showing me my 30 different tabs. How convenient of you. I'm hunting. It doesn't show me a picture of the window.
It's so not intuitive.
Supposed to come up with a name. What a loser design. All right, well, that's not working either.
I still think if you press share, then it comes up and says screen on the left and window on the right with number.
Which of the 30 things is it?
Well, I would just choose screen on the left, which will give you the whole of your screen. Then whatever you choose will appear. Oh, you don't want to do that.
Give the right picture. I'm not going to share all strange things I'm doing here. It's a window, and you are showing me tabs, Microsoft. Why?
Oh my gosh.
I have to look for...
Am I the only person wondering what Ted is doing on his computer that he doesn't want to show?
Correct. Yeah, well, go ahead and keep thinking. That's the way I want it. It's showing me tabs. Is it showing me window? I don't see windows.
If Ted can't figure it out,
I see tabs. This is stupid. Okay, I'm sorry. I suppose up on the top. All right, here we go. Now we're coming. At the top, when you start to share, Adrian, there's a choice between Chrome tab, window, and entire screen. And now that I click on window, here we are. Pardon me for my delay. I'm slowly learning. All right. The Happy Tales starts off nicely. Here's a nice big dish we had up in Estes Park, which is northwest of Denver, Colorado in the U.S. It's about 40 minutes west of me, so I drive up the hill. That's where Rocky Mountain National Park is. It's a gorgeous park, lots of elk. Anyway, but they have this nice dish, and I learned how to work on it. But then about 2 years ago, big winds came. They said 100 miles an hour, and it bent the dish over terribly. It's just sad to just look at this thing. 100 miles an hour, bent it in half into a taco. So we took the antenna off, and it sits in my backyard for parts. But let's put something in place. So this poor little stub is sitting there. It has been collecting nice signals. They're not too noisy. These are spikes from the galactic plane going past. I did several declinations bouncing around here. And so when you plot them up on the sky, yeah, okay, I'm getting the bumps in the right places. This is all good. There's one line way up here with a little dot. Actually, I'll show up better now in the next picture. There's the green dot, and that's the one I need to go up there and collect. And then I think I'll move it one slot down here in the middle to collect through that space. But here are the lines so far, and sure enough, the bright things line up with the galactic plane. If you interpolate the data, well, with all the missing data points, let the computer predict what they should be. It kind of comes up this way, and because I'm missing data up here around 50, it's misleading, so I just need more data, right? It is nice, though. One of the interesting samples at apparently 63 degrees galactic longitude came up with a nice double bump. The one on the left is actually the outer galactic arm. If you take all of those and line them up like slices of bread, it kind of looks like this. We start to see patterns. Here's that double bump shown right here in the middle. And if we then take this and rotate the top up here over to the left and change it to color for the bright peaks, it looks like this more traditional plot. And I'm slowly trying to fill this out. I guess the professionals want it to look like this, where there's a nice triangle here in the middle, and down below there are some hanging beads, I call them, ropes maybe. The outer ones, the lower ones down here are for the outer galactic arms, and this triangle is the inner galactic arms, it turns out. If I back up, this is what I have so far, and it's trying to do a triangle in here, and maybe there's a hanging bead down here because of this guy. So we'll see. And so when you plot it with distance, sure enough, we see the Pisces arm. Okay. And maybe there's an arm out here on the two on the left. So more data is needed. So that's what I'm going to do. Probably tonight I'll run up there and get some more. Of course, Ezra is what's making all this happen. Use other methods, that's fine, but this is what I've come up with. I offer it in case you want to give it a try. That's it. Questions?
I was just thinking, Ted, in terms of integrating data, perhaps, for example, if we thought about integrating data from your telescope with from mine, I suppose ultimately what I'm talking about is the SHOES project, really. But can you actually just combine the EZB files together?
The program will do it, sure, but they're probably different levels. I'm assuming that your antenna is receiving the same way each time you write down samples. It could be that in the winter months, it has a different temperature, and therefore it has a different gain. I think I've seen that over a very long period of data collecting compared to the summer. And so that's a problem. What we should do is eventually get this thing so it's actually calibrated, meaning some number that we write down has meaning. Right now it's all relative to each other. And that's why I keep assuming that you didn't change anything and it's recording the same way as before. That's good enough to start with. I'd like to do calibration. I've got some ideas. The other thing I could do is just plain cheat. Is there a method to look at the relative, in a large view, what the power levels are of these traces, and then match them from day to day, month to month, kind of thing, or your antenna to my antenna? The Ezra has a way to, well, already if we combine EZB files, there's no more conversion necessary. In that file is the right ascension declination, and that's independent of where you are on the Earth. So we could combine files. But there is a sneaky thing in EasyCon that allows you to change the gain, and I'm not sure at what level, maybe for the whole process. So if you did day by day, you could change it individually day by day. And that might be good enough to combine antennas as well as month to month. Anyway, these are the things I'm thinking about. This all has to do with intensity or maybe frequency. And the frequency, well, okay, yeah, the frequency has intensity as well. And so we haven't really tried to combine from antenna to antenna. Be a fun experiment.
Well, perhaps you and I should have a go at that.
Yeah, that would be interesting. Because eventually, of course, I want to fill in places that I can't see because the Earth is in the way. And I just haven't given that a try yet. You and I see the same stuff. What we really want is Australia data.
Well, if we can show that the system works, then we can then put out a begging letter for people from Australia.
Well, of course, we kind of have. That's what started shoes. So we're waiting. Also, Australia would see quadrant 4 over here. And I have just never processed a quadrant 4. It'd be interesting to see what we get. Most of quadrant 4 is blanked out for me in my Earth location. But that's going to have to come up here eventually. Every time I look at the professionals' charts, their quadrant 4 is not as good as the quadrant 1 over here on the left. And it could be that there's stuff out there in space that's blocking our view, and maybe we just don't get very good data in quadrant 4. Or it could be just, again, that the observers are in the northern hemisphere and they can't see quadrant 4, and their data for quadrant 4 is somehow of a different quality. Sure, we should try to combine some data. Let's see, what do I want? I guess I want .text files from you, but just a couple. Let's see what we can do.
Okay.
If someone in Australia were to collect the data and actually process it, could you then merge the two after post-processing?
Yes, and then we have to worry about that in the system gains that might be different. And so I think there's a way to fake that. It's probably a parameter in EasyCon that I don't advertise, although it is documented inside. It's just commented out. What you're doing is now changing your data, and that's just not very polite. You can make your data say everything if you got that kind of knob.
Yeah, if you had a referencing, I mean, professionally, I guess what radio astronomers use is the detection of from some of these standard quasars, and they focus in on one of these quasars that are fairly stable signal, and then they use that to sort of calibrate the overall sensitivity of our observations. But I don't think we have.
What Andrew and I could do is just take long exposures of Polaris. Polaris might rotate, but I don't think that'll change anything in our antennas. And we could make something, find the knob settings so that those are the same, and then it'll apply it to all the other places of the sky.
I see. So whatever the signal is coming from that spot, and they just normalize to that.
Yeah, there are other standard places. I'm not sure if they're good enough for our small antennas. Our antennas see that small place like S7 and every other star around it. You know, it's just too big a field of view.
Yeah.
All right, neat ideas.
Okay. So, anything else you'd like to talk about, Ted?
I think we're doing fine.
Okay.
Nothing exciting and newsy as that. Oh, well, no, I'm working on one more program.
Oh, what's that?
Let's see. Maybe 3 weeks ago, there was a suggestion, we really don't have anything to convert from one coordinate system to another. This point up in the sky, it's right ascension declination, okay, but what is its galactic coordinates? Because I want to know where it is on the galactic plane, kind of thing. Okay, but everybody has a different location on Earth and a different time that they're measuring, and so that changes the as-L to point to that one place in the sky.
Mm-hmm.
And so I came up with a program called Easy Dec to tell you if you point your antenna up at this place in the sky, what is the declination that you're looking at? Where are you drawing the line across the sky that I was just showing, all those horizontal lines? And then, of course, where does that declination intersect with the galactic plane, if it does? Tell me those galactic coordinates so I can start collecting, like stamp collecting, I want them all. And so that program's coming along. It's giving me nice numbers. Are they truthful? I'm not quite ready to release it. But it looks good.
Do you know, that would be quite helpful, because Alex always keeps saying, oh, just give me a measurement. I think it's at 40 degrees declaration or something. And I had terrible difficulty trying to work out what elevation is going to give that to me.
And where is that in an hour from now? Yeah, all that kind of stuff.
Yeah.
Mostly if we do drift scans, though, I just want to know the declination. And somewhere in 24 hours, we'll get every dot on that line.
Yep.
And then, so where did I end up on the galactic plane? What were my headings? That kind of stuff.
Indeed.
So that's the other news that's coming along, I guess.
Oh, wonderful.
Does the software, does that calculate in sidereal time?
EasyCall has sidereal, but I don't know why that's useful to us.
Well, if you did long-term observations, obviously the time difference would be from just a normal 24-hour clock would shift that position, wouldn't it?
Before computers, people used sidereal time to compare. Nowadays, we let the computer do the conversion more simply. And so I think sidereal clocks are not as useful as they used to be. It used to be a standard, but heck, now we just tell you where you are on the Earth, what's your as and L, and what time it is, and let the computer figure out all those details. It just seems simpler on the user side, much less and easier to come up with a clock rather than that I actually believe you got the correct sidereal time in your data, because it's harder.
When I was putting my software together, I got the coordinate conversions from a book, coordinate conversion with a spreadsheet, and you could download all the spreadsheets as well. So that's what I used to develop the coordinate conversions that I put into my own software.
Excellent. Okay, good. I'm about to probably put in the journal a article for each half declination degree. Well, let me say, each declination half degree, what are the galactic coordinates you run into with a drift scan? To me, it's a nice lookup table. All these coordinate systems.
Did you have any luck finding your picture that you wanted to show us, Adrian?
Well, I have the picture. I'm not sure if this thing will.
So give it a try. Do a share, and then along the top you'll see that you have three choices. One that talks about tabs on the left, and another one in the middle clicks for picture, for window. I think you want to click on window.
Okay.
And now you get to three pictures. Do you see the choice in the middle?
Yeah, I see that, but I can pop up my it's from an Adobe PDF file that I have the picture in.
Do you see the picture?
I can pop it up in my screen, but I don't see. Oh, well, it was there for a second, I thought.
You have to go to Windows in the middle.
I am in Windows in the middle. I'm in Windows in the middle.
And I would think that it represents each one of those windows somehow, right?
Well, oh gosh.
You have to find it.
See, I had to, in order to switch over to this, I'm not using Chrome now. I'm actually using the Windows Edge browser, and I'm not sure if that.
I don't think I care. I think it's just a window.
Well, I see the windows. I see actually one window, which is the one with all the participants, and then I see a window that that's like a directory, and then my desktop, kind of. But I keep popping up. I can pop up the.
I see 6 of them, and I can scroll down and see more.
I scroll down, and I don't.
The other option, if you press the share button, it says screen on the left hand side, window on the right, but screen on the left hand side. If you click screen, that means that whatever you see on the screen is what you're sharing.
You don't see alt tab around.
You don't see the picture now. Okay, well.
Have you pressed screen?
I have, yeah. I pressed screen and
the share button at the bottom.
Well,
you have to enable it. You got to pick something, and then things are happening.
Is that coming through now?
Yep.
We see your screen because we see ourselves.
Oh, then it's not.
Now, can you alt tab to the one you want?
Okay, let's try to go to that. Let's see.
I said alt tab. That's a keyboard button.
You've just left your share now because you closed the share down.
Right.
So you have to do it again now. Press share again, and go back again where you were.
I have.
Entire window on the right.
Entire window.
And then
share.
Press go. Great. Now, if you just hold your keyboard alt key, okay. We see a pretty picture of Orion.
Oh, okay. So it's going through. Okay. So yeah, that was a raster scan of the Orion molecular gas cloud that I did a while back using the GBT. So as you can see there, it definitely shows up as a nice big blob of. It says 1658.9 up there, but it's I actually tried to set the 1665. I don't know why it gives that particular frequency number, but that was what I was aiming for, the 1665 Macer hydroxyl output. And so yeah, it's pretty bright with the GBT.
This is off the 20 meter?
Correct, yeah, right, the 20 meter green bank dish, right.
I made a converter to take that data and it comes down in several different forms. You got to make sure we are matched, and then even throw it into Ezra. I was trying to recreate this image, for example.
Okay. So I've done this twice. I did this. I actually first did it about 6 years ago, when I was able to take Greenbank was during the COVID era. They did online what they called the single dish school, where they had week-long instructional class on using single dishes, and so that's when I first gained access to the 20-meter Greenbank telescope. This one was done more recently, and so in any case, that's one way of observing that macer. As you can see, the angular resolution even of the Greenbank radio telescope is not enough to. There's multiple macers in that molecular cloud, and the only way you can see them individually with the kind of resolution needed would be with VLBA interferometry, and so those have all been mapped.
Good. So what's your account for that?
I'm sorry?
Let's use the VLA. Yeah, that sounds good.
Oh, well, if we had access to it, it would be, maybe if we had an inside contact there that would hook us up. But I think with a Greenbank, the 20-meter dish is still a fantastic instrument to use. And so I'll stop sharing that if anybody else has anything to do. But yeah, it's a fantastic instrument. Like I said, I should utilize it more. But again, those scans require a few the credits that are allowable for the SARA account. And I know people are doing maybe more interesting work like what Andrew is doing, maybe with these extragalactic observations that are really fascinating. And I want to leave some of the credits for them. I think that scan gobbles up something like about 300 credits, which is a little exorbitant. So I know you guys can get a lot more data with just utilizing 20 or 30. So that's fantastic.
I wouldn't bet on that. Jason and I shot through nearly 200 credits the other day.
Well, see, but that's multiple observations probably, and that is not just one single raster scan.
Well, but a raster scan does multiple points. Each of our points were 22 credits, and that was really seriously limiting down to basically 1 second, 5 repetitions of 1 second at each data point.
Yeah.
So it can take quite a lot of credits, but. Rich so far is actually keen that people should use it. I think he feels it's not being used enough, and they were ironically very pleased when Jason and I managed to wipe out the credits a month or two ago, because it was the first time ever apparently they'd had to buy a second set of credits for the year. So I don't know how they feel when this one goes again and need to buy a third set. The way it's going at the moment.
I have a reserve about 1,100 credits from that class that were given to the students that I've never utilized. So if Sarah ever decides not to renew it, I can maybe just still get on there and do a couple more of my extensive raster scans before I wipe those credits out. They last, I guess, forever. They're, like I said, they're about 6 or 7 years old, so they don't get erased. They're there permanently.
All right.
So, but I think this last scan, I used the Sarah points.
Well, as I say, I don't think Sarah's too concerned about at the moment about people using it, as long as you do it for something that's of interest to everyone else.
You know, the thing that I'm scared of is that we'll lose the whole Greenbank system. I'm leery of some of the budgetary shenanigans that are going on right now with NASA, with research. I'm actually a biologist. I do molecular biology, and so I still keep up with even some friends and stuff that are still doing research, and the cuts that have been made to university laboratories for biomedical research is just incredible. I cannot believe that this is happening, but it is. So, I mean, I've heard rumors of things getting shut down, like the VLA, Greenbank. turning off the transmitters on the Voyager spacecraft. I mean, stuff like that, which is a lot of the space probes maybe just being eliminated from funding for the ongoing observations. I hope it's not true.
Yeah. Anyway, it's now 10 to 9, so I think it's probably about time that we should be closing up the meeting formally. I don't mind if people wish to continue to stay on and chat, but certainly as far as the meeting's concerned, I think the formal meeting, I think we should bring it to an end. So in terms of the next meeting date, I mean, we have been doing this once a month. I'm going to, before we carry on though, I'm going to just close down the recording. Let's just stop that. Excuse me.